Right, hello, welcome. This is a, well, I'm not exactly sure how this is going to be put, to be honest. It's just another bit on binomial expansion that, A, I don't think I added in my last video, and B, I might have got a bit, I might have confused you. Right, I might have got it wrong completely. So anyway, in this video, I'm just going to be going over some corrections that I'd like to make in my last video for binomial expansion. And I'll just be going through some questions from the, if you're in my class, the C4 homework book that we've got given. Otherwise, I'll just be going through some standard questions. This pen's annoying me. So anyway, what did I miss out, or what do I need to add? There's a few things. There's only two. You might get a question. Generally, for A2, you have to use this formula where it says 1 plus AX to the power n, and then you explain that when it goes 1 plus AN plus n take 1 over 2 factorial, which is 2 times 1, times a squared, and this number increases, and you generally get the expansion. Okay, so that's what you normally have. But sometimes you get something like this, where it's 3 plus 2x to the power n. How do you make that equal to that? Because this only works for integers positive, where it's 1 plus a. This is not in the form of 1 plus a, this is 3 plus a being 2 in this case. So a can change, a can be anything, but it's just what would the first coefficient that isn't x has to be 1, and this isn't. So how do we make this into that formula? So let's call n, in this case, I'm going to call it 2. So it's 3 plus 2x squared. So how do we put that in the form 1 plus ax to the power n? Well, obviously, we have to take 3 out as a common factor. So if we put 3 on the outside, and then it's 1 plus 2x over 3, and that's squared. However, this 3 that we've taken out is not just a 3. Oh no. It's all of this is squared. So therefore, the number we take out is going to be squared as well. So this isn't just 3. This is 3 squared. Therefore, is 9 1 plus 2/3 of x all squared. So that's what that is in the form 1 plus ax to the power n. Now obviously we've taken out a 9 as a common factor there. So then we just do the standard expansion as we normally would, except we do all this expansion for this one and we times it all by 9 afterwards, because we're taking 9 out as a common factor to allow us to perform this. So that's what you do. I think I did miss that out. Well, I might have covered it in my last video, but I definitely didn't talk about 3 being, you had to take out the power as well. I think I just took out the number. So anyway, that clears that up for you. Okay, so the other thing I wanted to talk to you about is, just rub this off. So sometimes you'll get a question, and it'll be something like this. It'll say expand. So if we use that 3 plus 2x. Well, let's call this the power 4 actually. And you'll expand that, and you'll be very happy. And you tickety tick tick tick. Okay, you get full marks from that say. And then you get a part C, generally part C or B, and it'll say, oh, this number, which call it 0.18 for example, oh, is also incidentally to the power 4. And it says estimate that. Now in C3 you've got a calculator obviously, you can just whack that in your calculator. But what does that, because what you're supposed to see is this is to the power of 4 and this is also to the power of 4. Now they won't be directly in the same part of the same question, but so that'll be a part A, expand that, and this will be a part C. Now you don't need to use your expansion of this, put it equal to that. Because they're both to the power 4, then this equals 3 plus 2x to the power 4. And because they're both to the power 4, then they must be equal, because something to the power 4 equals the same thing to the power of 4. But just the fact that the number is split up, in this case, into 0.8 and 3 plus 2x. So therefore we could just ignore the powers essentially. Obviously you could cube root both sides, not cube root, quad root both sides even. I was thinking of the word there. So therefore it's 0.18 equals 3 plus 2x. Now I've just made this question up, so it's going to be ludicrous in terms of what answer you're going to get. It's going to be minus something, which generally you wouldn't get. So, but this is the purpose, the method is the same, it's the key thing. So therefore it's 0.18 over 3, it's not over 3, sorry, 0.18, take 3 over 2, and that gets you x. Okay? And then that's your approximate value for x or something. And you approximate value for x, and that'd be your answer. You don't need to worry too much, as long as you get the fact that you have to spot the both to the power 4 and remove the powers or quad root them or whatever root it may be to get the x on its own. So when you see something that says, you generally would work this out as an expansion in the first part of the question and say find the quadratic approximation. Just means expand it until we get up to x squared, which will be the third term in this type of question. So hopefully, as I said, that makes some kind of sense. Right, so that's the two things I've got out of the way that I missed out in that video or in the binomial expansion video, and I just didn't justify it well enough. Now, this video is not just about that, otherwise it'd be a waste of my time doing it. Well, it wouldn't be really, but you know, it'd be quite easy actually for me to sit down and go, Christ, but that's not the way I work. Oh no, I'm going to do some maths. Well, what's the point? I am. So anyway, for those people that are in my class, your standard C4 homework book. Hopefully you've got that out with you. If you have, if you're in my class, otherwise, anyway, we're just going through some questions, as I said. So the questions I want to go through, they are a mix of the harder ones, because it's actually a mix of ones that are with partial fractions, and I want to go through a method with that. I couldn't just teach it you then, because I need a proper question to be able to demonstrate it to you. Otherwise, I'll just get myself in the middle and I'll get confuse you. So anyway, questions I want to go through for Binomial Series Expansion 1, which is the second sheet in your C4 homework book if you're in my class. I'm going to go through, sorry, double check, question 2, question 3, question 5, question 7, question 8. So that's question 2, question 3, question 5, question 7, question 8. So basically it's every question apart from 1, 4 and 6. So there's question 2, question 3, question 5, question 7 and question 8. So that's what I'm going to go through, because they're a mix of A, the harder ones, and B, the ones that we've just gone through now, so which I think is a good idea to attach to this video. The other questions, so 1, 4 and 6, are very, well, 6 is actually, that's one of the things we've just done, but I think that's quite an easy one, number 6. So 2, 3, 5, 7, 8. But anyway, for the rest of you, I'll just be going through normal questions. So question 2 says, you can get try to vary the pens and not just use one pen all the time. It's efficiency. So anyway, question 2 says, find a cubic approximation to the function f of x. And now we're told f of x is equal to, we've got the square root sign over 1 plus 3x. Now you should recognise straight away anything to the square root is the power of a half. So that we rewrite this as 1 plus 3x to the power of a half. They mean exactly the same thing. This just makes it easier for us to put into a formula. Now the cubic approximation is where you expand this until you get x cubed. So if we put this in our standard formula, so 1 plus 3x, we don't need to take 1 out of it because we've already got it in the form 1 plus ax to the power n being a half in this case. So therefore, if we follow the standard thing, it's 1 plus an. I always put this in brackets, so it's 3x times a half, so obviously that's 3 over 2x, but we're not going to simplify it just yet because I want a line of working out. So so I can show you where we're getting the answers from, and then a line of question of simplification. So therefore, the next part is n times n take 1 over factor 1 over 2, n being a half, so it's a half times negative a half, which is obviously negative a quarter, over 2, which is negative an eighth. But as I said, I'm not writing any of this down, just writing a simple how we work it out rather than the answer, because we need to keep the lines separate. Times a squared. Now a is not just 3, it's 3x, so it's times 3x squared, so it's not, sorry, 3x all squared, so it's not just 3x squared, it's something 9x squared, but we'll leave that out for a moment. Now it says cubic approximation, so we need to go one step further. So if we do a half, take away 1, so it's negative a half, times 1 take away negative a half, which is negative 3 over 2, or 1.5, whichever you want to put. I'd keep it as fractions. That's over the factorial of 3, which is obviously 6, because it's 3 times 2 times 1, times a cubed, which is 3x cubed, which you obviously know is 27x cubed. So therefore, if we expand this out, we get to simplify this now. So it's 1 plus 3 over 2x, or 3x over 2, whichever you want to say. Half times a half, negative half. That gets us negative an eighth times 9x squared, which we get, because that's negative, we have to take that away. So it's negative 9/8 x squared, or 9x squared over 8. And now, because that's going to give us a positive answer, the next part. So that's a half times negative half, which is negative an eighth, times 3 over 2, divide by 6, which gets us 27, sorry, that gets us a 16th. And we have to times that by 27x cubed, so it's 27x cubed over 16. So hopefully this is generally what the questions are like on this homework sheet. So I'm just doing one of them so you can get used to it. Now the next question says, this is too big. It says state the value of x for which this is valid. So it's always the a value. So what generally thing is, it's minus 1. A is between minus 1 and plus 1, but a is 3x, so therefore it's minus 1 is between 3x is between minus 1 and 1. However, we want x on its own, so therefore we divide all of it by 3. So that's minus a third x is less than a third. So that's what you should have. You always give it in the inequality form. 2c. 2c is one of the ones that we did before. And then it says find the approximate value of the square root of 1.03, which you should know is equal to 1.03 to the power of a half. Now this is to the power of a half, so this is equal to that. So therefore, the square root of 1.03, or 1.03 to the power of a half, is equal to 1 plus 3x to the power of a half. Therefore, as we said before, because the powers are the same, you can square root both sides by just simply ignoring the power. That's the way I like to think of it, because I'm lazy, but you talk about square root both sides. But seeing as you don't need to explain that in the exam, just go ahead and ignore the powers, presuming they're the same, by the way. So therefore, it's 1.03 equals 1 plus 3x. And then you just simplify that down, so therefore you get x is equal to 0.1. So that's, 0.01. So what you do there is 1.03, take away 1, divide by 3, which gets you 0.01. So that's question 2 done. Just going to get the charger from my camcorder, just be a second. Sorry about that, I just had to nip off and get a charger there. So anyway, as we were saying, that was question 2 for the C4 homework booklet. So time to move on now. So just pump that out. Probably should have done that while I was changing over, but you know, I'm sure you'll love to see the back of my head. Anyway, let's read into that what you want. Anyway, so what we said we were going to do now is question 3. Now this one, question 3, is all about converting from, say, your coefficient. So the first one would be 9 plus 18x to the power of a half. Converting that to 1 plus ax to the power n. Okay, so that first one there, I said it quite clearly. So this is 3a for those of you that pay attention. So therefore it is 9 plus 18x to the power of a half. Now remember what we said, when we take out something, we bring it out with a power, so therefore common factor to both is 9. Generally it's always the first, so if it's 9 plus 18x, you always take out 9, and then if it's 8 plus 16x, you always take out 8. So whatever the first number is, you generally can always take that one out. Otherwise you won't be able to put it down to 1 plus ax to the power n. So anyway, let's do that. So it's 9, the power goes with it, so it's 9 to the square root of the power of a half, which is square root. And you're taking it out, so it's 1 plus 2x, but that power is still to the power of a half, we've not changed anything. So therefore, if we square root 9, we get 3, so it's 3 plus 3 brackets 1 plus 2x to the power of a half. So that's one question there, that's 3a. 3b. 3b is similar sort of thing, so 2 take 6x to the power minus 3. You don't have to worry about the power being a minus. I know the temptation would be to do 1 over that, but don't, because you'd just be wasting your life. I mean, you're watching this video, so, you know, obviously, it doesn't say much. So anyway, take out 2 as a common factor, so that's 2, don't remember that's the power of minus 3, and then that's 1, take 3x, that's still to the power of minus 3, therefore 2 to the power of minus 3, so that's 1 over 2 cubed, so therefore it's an 8th times, the rest of it doesn't change, so it's 1 take 3x to the power minus 3. As I said, that doesn't change. So hopefully these are quite self-explanatory. Number 3c is one that is a little bit harder to spot because it's not given to you straight away, but still fairly easy. So it's 1 over the square root of 4 take 2x, and that's the same as 1 over 4 take 2x to the power of a half. Therefore anything on the power on the bottom has been an x, it's a negative power, so therefore it is simply 1 times 4 take 2x to the power of minus a half, but you can ignore the 1, just making it 4 take 2x to the power of negative a half. However, this is not in the form 1 plus ax to the power n, so therefore you take out 4 as a common factor, but you have to remember the power stays with the 4, so it's 4 to the negative a half, or the negative square root. And because you've taken 4 out as a common factor, sort out the bracket inside the bracket, so it's 1 take x over 2, because x over 2 times 4 is obviously 2, but the power doesn't change, it's still negative a half. So it's a little bit more working for 3c, as you can see. So therefore, minus, so it's 1 over the square root of a quarter, which is a half, so it's 1 over 2, and the rest doesn't change, it's 1 take x over 2, and the bracket, so it's still to the power of negative a half. Now you could do, if you wanted to, do a half over the square root of 1 take x over 2 square root of that, but is you know, for doing, I leave it as that, and I think the exam board would want you to as well, because if you're going to do binomial expansion on that, because you wouldn't get a question that's just as easy as just rearrange this and put it in binomial form, you know, in the 1 plus ax to the power n form. It wouldn't be that easy because the examiner's nasty. So anyway, that's just question 3D. So I just wrote this out and then I can just leave myself enough room here. So as I said, if you get the hang of these, you can flick off now. However, actually, question 7's a little bit of a stinker, to be honest. So I'll just do 3D now. So 3D is, so I'm going through question 7 and 8, by the way. So if you want to stick around, just skip a few minutes. So 3D is 5 plus 2, sorry, straight up there. 5 plus, it's 5 plus x to the power of minus 2. So you do the same principle, even though it's just x, you need 1 plus x, so therefore you take out 5 as a common factor, bring the power, so it's 5 to the minus 2, and that's 1 plus x over 5, but still to the power minus 2. Rearrange this so it's 1/5 squared, So therefore it is 1/10 or 0.1, whichever you want to put. I'd put 1/10. Bracket 1 plus x over 5, and that's all to the power minus 2. So that's 3D all done. Question 5 is sort of mixing these with the general expansion, which sort of is 5's a little bit more difficult than 3. There's only 2 parts to 5, so there's 4 parts to 3, so you know, still pretty hard. So it's 2 plus 4x to the power minus 1. Now, for those, so that's 5a. Now we're at 5b beneath it, because what I'm going to do is I'm going to give you a chance now, for the people who don't have this booklet, just to have a go at these questions. So what I want you to do, if you're not in my class or if you've not attempted it yet, I want you to do the first 3 terms in each of them sequences. As I said, if you're in my class, don't worry, I will be going through these. Let's just give them a minute just to write it down. So, therefore, hopefully you've had a go at them. We're just going to go through the answers to them. So, therefore, you have to take the power out. So if you take a common factor of 2 out of the first one, that's 2 to the power minus 1, don't forget. That's 1 plus 2x, still to the power minus 1. So if we were to expand that for the first 3 terms, as it's asked us to, sorry, this is, yeah, you could do the 2 to the power minus 1 as a half. So therefore, it's a half times the expansion of that. So therefore, if we just expand that and then times it by half, is 1 plus a to the power n, a to the power n, so the pen's good. A to the power n being times 2x times 1, minus 1, sorry, plus minus 1, take away, times minus 2, over the factorial of 2, which is obviously just going to be 1, times your a squared, so it's just times 2x all squared, not just 2x squared. So therefore, what I like to do at this stage is I don't times it all by half yet, I expand it out, so each one of these, sorry, so it's 1 plus, take 2x, sorry, and as that becomes a positive, so minus 1 times minus 2 is 2, over 2 is 1, times 4x squared, so it's just plus 4x squared. So if we times that all by half now, expand out the bracket, so it's a half, take x, plus 2x squared. Okay, so that's a simplified version for 5a, that's what you should have got. That's how we got to it. 4 plus x squared is the power of negative half. Now don't be put off by the fact this is an x squared instead of an x. We use the same method where we put a in, just obviously we get x to the power 4 in this scenario over here instead of x squared, because we've already got x squared, and x squared 2 times 2 is 4, so that's why we get x4 in there. So don't be put off, that's just a quick heads up. So anyway, do the same thing, take out the power, so we take out 4, but we carry the power, so it's 4 to the power of negative half, and that's 1 plus x squared over 4, that's still to the power of negative half. If you wanted to simplify this, so it would be 4 to the power of negative half, so it's a quarter, the square root of a quarter, which is a half, which is similar to what we've done before. I think we did something like that before. So therefore, do the same thing as we did up here, where you take out the power of a half. So therefore, it's a half, and then you expand the normal bracket. So you expand that bit as normal. So therefore, it's 1 plus an, a being x squared over 4. So it's x squared over 4 times n being negative half. So it's x squared over 4 times negative a half. It's not take. I could not take a half, that's what I've written, but it shouldn't be. And as I said, this is once the third term, so we don't leave it there, even though we've got x squared is what we had up here, that's only the second term. Yeah, so therefore you add minus a half times minus 3 over 2, which is also going to be positive, over 2 times 1, which is 2, times a squared, which is x squared over 4, all squared, remember. So therefore, I'm going to do what I did before here, simplify this part before I expand it out. So there's a half, 1, take x squared over 8, or an eighth of x squared, which however you prefer to write it. That's plus, so negative a half times 3 over 2 is just going to be the same as doing 0.5 times 3 over 2, because it's going to end up positive anyway, which gets you 3/4, you divide that by 2, gets you 3/8. 3/8 times x squared over 16, so it's 3/8 times 1 over 16, and then we're just going to put the x in on top. So that's 3/8 times x squared over 16. So we'll just work this out. That gets you plus 3x to the power 4, because it's x squared. So yeah, it's x quad, and then we say x to the power 4 over 16 times 3/8, which gets you 3x to the power 4 over 128. But that's not what we're finished with. We expand this out, so we get a half, take x squared over 16 plus 3x to the power 4. We can double the bottom, which gets us 256. That's your answer for question 5. Now the next part of this is, it's not a question. Great, it's flipped over on the sheet. It's a little bit different to what we've been doing so far. Question 7 actually involves partial fractions. And there's a little neat thing, which I think it becomes obvious anyway when you expand. The method doesn't change in terms of the expansion. It's just what you do when you're faced with partial fractions. Because I'm assuming you're familiar with partial fractions, and if you're not, please do check out my other video on that if you want to bore yourselves to death some more. If you haven't had enough already, if you've just had enough for life, just watch my video. I'm sure it'll finish you off. It's put me to sleep a few times, so it says something. Anyway, question 7. This is, as I said, a little bit more difficult than the ones we've been doing so far. Just purely because it's, right, okay, what do I do now? The first part isn't so difficult, because it's just partial fractions, which is easy. It says, write the function f of x, and f of x being equal to 4 take 5x over 1 plus x 1 take 2x. Actually, I think I'm just going to do this question then, get off, because I don't think you're going to want to watch much more. So that's a over the first factor, so it's a over 1 plus x, plus b over the second factor being 1 take 2x. Okay? So what we do is that we times all of it, as we normally do, by the denominator of the first fraction. So that gets rid of 1 plus x in 1 take 2x in the first fraction. So 4 take 5x equals a. And if you times a by 1 plus x and 1 take 2x, the 1 plus x is cancelled out, so a is just times by 1 take 2x. This is the way I think of it, because some teachers say, oh, use, when you've got two fractions, the coefficient of a is times by the denominator of b, and b is times by the denominator of a, which works for dual fraction, or a partial fraction is split into two coefficients. However, it doesn't work for 3 because it gets a little bit more difficult. So I just say times them all by the bottom, the denominator of the first fraction. So as I said, that's just a little recap on partial fractions, which just I'm assuming you get the odd person who won't be bothered to watch that. Well, the odd person, all of you. I don't mean to say you're all, I mean just doesn't matter. Get myself into a muddle. Anyway, so what we have to do now is make one of these equal to 0. So I'm going to choose the b factor. So 1 plus x is 0, so that x equals minus 1. So therefore, it's 4 times 5. 4 take 5 to the 4 take minus 5, which is obviously going to be 9, but I'm just going to keep it, just going to replace x as minus 1 for the moment. So therefore it's a 1 take minus 2, so it's going to be 3a. b, as we know, because the factor of b is going to be 0, that just b times 0 gets rid of b. So I don't need to write plus 0b. Therefore 9 is equal to 3a. Therefore I make a is equal to 9 thirds or 3. Do the same method for b, so therefore we want to make the factor of a 0. So 1 take 2x is 0, so therefore x is going to be equal to a half. So therefore 4 take 5 times a half is equal to a factor 0, so 0a, just going to ignore that, plus b is times 3 over 2. Now what I'm going to do at this stage, which is quite sneaky actually, to make it easy for myself because I'm lazy, I'm going to times it all by 2 so we can get rid of these fractions. So therefore it's 8 take 5 equals 3b. Therefore 3b equals 3. Therefore b equals 1. So you just rewrite that as 3 over 1 plus x plus, and then we said b is 1, so it's just 1 over 1 take 2x as such. So as I said, that's just a quick recap on partial fractions for question 7a. So that shouldn't be too difficult, but the next bit is a little bit more confusing. You have to remember for this, anything over itself is the power of -1. That's the key bit of information for this next question, which I'm not going to let you have a go at, because if you don't know how to do it, I'm presuming that's why you're watching this video. So it'll be a bit cruel of me just to throw it on you to have a go, because I don't think any of you would. Anyway, so the next question, so 7b, multiply, says, hence, finding appropriate series approximation for each of the two parts. It even tells you what to do. Wouldn't do that in the exam. It just say, they give you the partial. It just give you the 4 take 5x over 1 plus x, 1 take 2x, and say, find the quadratic approximation to f of x. You just say, find the quadratic approximation to that. What you should be able to spot is obviously you need to split it up into partial fractions, because you've got two factors in. You couldn't just put that to the power of x squared, because obviously that'd take a bit of faffing around. So what do you need to do? Well, you need to focus on these two partial fractions, because in the homework sheet it wouldn't just ask you to split up for no reason. So therefore, another way of writing 3 over 1 plus x is 3 times 1 plus x to the power of -1. And another way of writing the 1 over 1 take 2x is 1 times 1 take 2x to the power -1. Now, these two look exactly like the kind of formulas that we've just been doing for your quadratic approximations. That just means expand that to the power where you get x being x squared. So what we need to do is we need to do the quadratic approximation of 3 plus x to the power -1 and add that approximation to 1 times 1 take 2x to the power -1. So they're already in the form 1 plus ax to the power n, so we don't need to worry about that. They could be a little bit, the most cruel question they could ask, personally from my point on partial fractions, would be this kind of question where they say, find a quadratic approximation to this, in which you would do split it up to partial fractions as we've done, and then do this, and then do the quadratic approximation of this, add it to the quadratic approximation of this. The only thing they might do that's a little bit more tricky to watch out for is you have to make sure this is in the form 1 plus ax to the power n. Otherwise you'd have to rearrange that, and that'd be even more faffing around, and I'm sure that'd end up being like 90% of the paper if I had my way. So anyway, the first one I'm going to sort out is this 1 plus x to the power -1. So therefore we do it in the same way. So we do 3, take 3 out. Well, 3 is already taken out, but then we just do the 3 times the quadratic approximation of this, which is a fancy word for saying getting up to x squared. A is x, n is -1, so therefore it's 1 plus an, so therefore it's 1 plus x times -1, which is obviously just take away x, but we don't just write that because mathematicians want to seem smart. So obviously, the thick mathematicians. So anyway, it's -1 take away 1. So it's -1 times -2 over 2 times 1. And generally, because we have to do so much extra work, they won't ask you to expand it up to something. They'll only generally ask you to expand it up to x squared if it's something like this. But if you just doing it on your own, it'll generally say up to cubic approximation, but this is a quadratic, so we only need to do it up to x squared. So therefore, that's times by a squared, a just being x on its own, there's no coefficients in front of that, so therefore it's just x squared. So I'm going to leave that up, I'm not going to simplify that, because I can leave that to you, hopefully you can write the answer. So that answer would be 3 times 1, take x, and then this would just be x squared. So it's 1 take x plus x squared, so therefore it would be 3 take 3x plus 3x squared. But I'm not going to write that because I'm trying to keep it on one board here, as I'm quite had enough of this already. So therefore the next part of this is 1 times 1 take 2x to the power of minus 1. Doing the same way, we don't need to take 1 out, we can just ignore that because it's going to be itself. So that's 1 plus an, so it's minus 2x, not just 2x, times minus 1, which is just going to be obviously plus 2x, plus minus 1 times minus 2 over 2, which is 2 times 1, sorry, which is just going to be 1, times minus 2x squared, which obviously gets you 4x squared. We're going to square the whole thing. And then what you do is you do your answer to your first one, so that'd be 3 take 3x, which is plus 3x squared, which is just your answer to your first one of this approximation, plus your answer to this, which will just be plus 1 plus 2x. That's going to be 1 times 4x squared, which is just going to be plus 4x squared. You simplify that because what we've got here is we've got the quadratic approximation of the first partial fraction plus quadratic approximation of the second final fraction, which we know these two partial fractions are equal to this fraction here. So therefore, the quadratic approximation of these two added together is going to be equal to the quadratic approximation of this one. So therefore, we split these two up. Split this up into these two, worked out the quadratic approximation of these, the individual ones, and then added them up. So that would leave us with 7x squared. Get the x together, that gets us negative take away x, and then that will get us plus 4. So the end answer is 7x squared take x plus 4, which is the quadratic approximation to 4 take 5x over 1 plus x times 1 take 2x, and then the denominators. So hopefully that makes some kind of sense. As I said, it's just partial fractions, then you just meant to realise, obviously if they were powers on the bottom there, then that would be a little bit more tricky, but generally you'd only have x squared in partial fractions at A level. You wouldn't take it up to x cubed at university. Obviously I've got several degrees in maths, as you can tell. So that's question 7. 7c says state the range of values of the x for which this is valid. I don't want to go into that, but if you're interested, it is so what put so just double actually no, yeah, if you're interested then just comment and I'll give you that one. Otherwise if I try to explain that, I'll just make a mess of myself, not my pants, just because I can't think of that one. And then the next one, question 8, is very similar to that. So if you've got that method, you can apply it to question 8. For those that you're wondering what question 8 is, it says find the first three terms of 1 over 1 plus 3x. That's the first part. And then the second part says 1 over 2 take x, which obviously it's just the first part is 1 over 1 plus 3x is 1 plus 3x to the power of minus 1, and the second one is 2 take x to the power of minus 1. And then it says find a quadratic approximation to them two fractions added together, which is just the answer to question 8 part 1 and question 8 part 2 added together, and then that's pretty much just exactly what we've done here, but maybe a little easier. So anyway, that's I've just tried to throw in a bit of information there for you. So hopefully that's been of some use, and I've rectified my mistakes for binomial expansion. I think I'll probably end up putting this as a separate video because it's about 25 minutes long, so it'd be quite awkward for YouTube to upload a video that's 50 minutes long. It'll take me several hours. Well, I'll say several hours, several years of my life. I'll probably still be uploading these videos, and I'll probably be a professor or something by now. obviously, because I'm not that already. So anyway, thanks for watching. Well done for sticking through it and surviving. And you know, if you just skipped to the end, I'm disappointed. I would have preferred me to pretend like someone was possibly listening out there. But anyway, thanks for watching, and we shall see you in the next video.